So today we're going to cover Chapter 6, Section 5. Today we're going to cover inequalities in one triangle. Now, if you are reading your textbook, also covered in Section 5 is something called indirect proof. You will not be responsible for writing indirect proofs. It is not on any kind of standardized test, so we're not going to cover it. Let's go ahead and see our first theorem, which is called the triangle longer side theorem. And what this theorem states is that if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So bottom line, the bigger angle is always across from the bigger side. So here what I'm going to do is look at my two side lengths that have numbers here. The first side I see here has a 10. This is side AC. So I can see that AC is 10. So I'm going to say AC is equal to 10. And then I also have AB here that equals 12. So AB is 12. And then I'm going to compare. The bigger side is AB because 12 is larger than 10. So the angle that is across from the 12 is angle C. So angle C is going to be greater than the angle across from the 10, which is angle B. So angle C is greater than angle B, or you could say angle B is less than angle C because it's across from the shorter side. Okay, for the next theorem, this one is called the triangle larger angle theorem, and this one states that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So now I'm going to look at the angle measures and I'm going to try to determine which side is longer. So the 30-degree angle, angle A, is opposite to side BC here. And then the 60-degree angle, angle C, is opposite to side AB. So I'm going to go ahead and compare. So I'm going to take angle C, which is 60, and then angle A, the measure of angle A, which is 30, and then I'm going to compare the numbers. I can see that 60 is larger than 30, so angle C is greater than angle A, so then the side opposite angle C, AB, is going to be greater than the side opposite the smaller angle, which is BC. So AB is going to be longer than BC because it's opposite of the bigger angle. Now, if they ask you to find the largest side or the smallest side of the triangle and not just compare between the two that are given to you, you also have to find the missing third angle. So let's say if I change this problem, and let's say I draw it like this instead, A, B, C. If they gave you that A was 30 and B was 60, you could add those two and get 90 and then subtract the 90. And that missing angle C is 90. So here, it's a right triangle, so I could have seen that. But if they didn't have the little box there, then I can see it a little bit better. So now to compare my sides, AB here is across from the 90-degree angle. This is going to be the biggest side. Then the next, and then the smallest is going to be opposite the smallest angle. And that's going to be 30, across from the 30. And then across from the 60, this will be like the middle one. So if it asks you to order them least to greatest or greatest to least, let's do greatest to least. you would have to find the missing angle first. So you would have said that AB is the biggest. And then the next biggest would have been the AC. And then the smallest would have been BC. So if they ask you to find the largest or the smallest or even order them, you need to make sure you have all three angle measures. Now, when you're doing the homework tonight, you're going to get a question like this where you have to find a missing angle to determine the biggest side. I want to see it. Even though the calculations are going to be easy numbers, I still want to see how you're adding and subtracting from 180. So even though the work tonight for the questions are simple, and some of them are just adding like 2 plus 2, I want to see it. Or 10 minus 5, I still want to see that. Even though it's mental math, I want to see it because I'm still seeing people who are struggling with simple addition and subtraction. So make sure you're showing the work for the questions. Now, if they've already given you all three angle measures and you're not doing any calculations, you're just looking for the biggest or the smallest, then you don't have to show work for that type. But the majority of the questions have a little bit of calculation involved. Let's go ahead and look at the next example. So the next slide is the triangle inequality theorem. And we use this to figure out if three numbers or three sides that are given to us will form a triangle. So what this one states that the sum of the lengths of any two sides of a triangle is going to be greater than the length of the third side. So what we want to do here is add two sides at a time, and then it always has to be greater than that other third side that we didn't add. So for example here, they're adding BC plus AC. That sum has to be greater than this side AB. And then if you were to add AB plus AC, that has to be greater than side BC. And then lastly, if you wanted to add AB plus BC, it has to be greater than AC. Now, you could also list these in reverse. You could have also called this BA, or this one CB, or this one CA. The order doesn't matter. So if I give you three numbers, you're applying the triangle inequality theorem. However, I'm going to show you a shortcut. So the shortcut is to figure out if three numbers will form a triangle. You are going to add and subtract the two smallest sides and if the third side is in between the sum and difference, then the three numbers form a triangle. I'm going to show you an example of this. So instead of having to add and subtract all three sides to see if it's greater than that third side and do this three different inequalities, all you need to do is take the three numbers I give you, and then you're going to add and subtract those three numbers, the two smaller numbers, and if that sum and difference, if that third side is in between that sum and difference, then it'll form a triangle. So for example, let's say I gave you the numbers 3, 6, and 7. And I want to see if these three numbers will form a triangle. So what I'm going to do is add 3 plus 6, the two smaller ones, and subtract. And if that third side, the 7, is in between 3 and 9, then I know that these three numbers will form a triangle. So it has to be greater than the difference, but less than the sum. Okay, so the third side must be greater than the difference and less than the sum. So for example, we would have had the difference in 7 and then the sum. So 3 was the difference. So 7, the third side, is greater than the difference, but less than the sum. So because 7 falls in between 3 and 9, those three numbers, 3, 6, and 7, will form a triangle using this triangle inequality theorem. So our first theorem, our first example wants us to use the theorems that we just learned, and it says to name the largest angle and the smallest angle. Well, to find the largest angle, I need to find the biggest side, and my biggest side has a length of 10. So that biggest side is AB, and the angle across from AB is angle C. So angle C is the largest angle because it's across from the biggest side. To find the smallest angle, I need to find the smallest side, which is the 6. And the smallest angle will be opposite to that side, and it's going to be angle B. To find the longest and the shortest side, I need to look at the angle measures. Now here it's not asking me to compare just the two angles that are here. I need to find the missing third angle first. So I'm going to go ahead and add 46 and 105. And that is going to give me 151. I'm going to subtract that from 180. And my missing angle, angle T, is 29 degrees. Notice by finding that missing angle, it made a difference because 29 is my smallest angle. So that is going to help me find the shortest side because 29 is the smallest angle. So the shortest side is going to be IJ, or you can say JI. Now to find the longest, I need to find the biggest angle, which is the 105. So the longest side is going to be IT or TI. It's always across from the biggest angle measure. You needed to find angle T first before you could figure out the biggest side of the triangle and the shortest side of the triangle. Next one, complete. And they want us to fill in either a less than symbol, an equal sign, or a greater than symbol. Notice a picture is not provided. I'll go ahead and sketch one. I'm going to draw a right triangle, and they're telling me the right angle is going to be angle C. Doesn't matter where I put A and B. So if you use your triangle sum, and you know you already have a right angle, and you subtract it, that's leaving you 90 degrees left over for A and B together. We learned a corollary a while back that stated that the two acute angles of a right triangle are always complementary. So always remember that the biggest side of a right triangle is always going to be that side opposite the 90 degrees. So angle C is the greatest angle here because 90 is left for the other two because they're acute. And again, using the same rule here, that 180 minus 90 leaves me 90 for A and B. So angle C equals A plus B. And again, AB is the biggest side, so AC is less than AB. All right, example 3. They're giving us two lengths of the sides of a triangle. then they want us to figure out what are the possible lengths for the third side. This is where I'm going to add and subtract. So I'm going to subtract and add the two sides that are given. So it has to be greater than the difference, but less than the sum. So in other words, if you wanted to translate this, it's always going to be the third side will be greater than the difference, which is the subtraction problem, and less than the sum. And that would be possible values for that third side. It cannot equal the sum and difference. It's got to fall in between. So let's say I call the third side x. This would be the inequality you would set up. It's got to be a number bigger than 5, but less than 21. Now, you could have fractions, so this is why I'm actually putting the sum and the difference numbers in here. Because the side length could be 5.5. You can get fractional sides. And now we're just going to use this same theorem on the next slide. We're always going to be adding and subtracting the two smaller sides to see if the given third side falls in this inequality. So let's try example 4. So for the first one, is it possible for a triangle? So I'm going to add the two smaller ones and subtract the two smaller ones. So 8 minus 6, 8 plus 6, 2 and 14. So the third side, the 10, has to be greater than the difference, but less than the sum. And this is a true statement, so this is yes. 10 is in between 2 and 14, which are the sum and the difference. Let's try the next one. Add and subtract the two smaller sides. So 4 minus 3, 4 plus 3, 1 and 7. So because 8 is not satisfying this inequality, 8 is not less than 7. This one is no. So it doesn't satisfy this part. It's greater than the difference, but it's not less than the sum. So this one would have not formed a triangle. One of the sides would have been too short. Then the next one, again, take the two smaller numbers. I'm going to subtract them. 4.1, 2.5, 4.1 plus 2.5. I get 1.6, 6.6. And again, the third side, the 5, must be greater than the difference, but less than the sum. So 5 is in between 1.6 and 6.6. So C is yes, they can form a triangle. Now, notice on part D here, it's not listed least to greatest. So my two smaller numbers are the 4 and the 2. So 4 minus 2, 4 plus 2, 2 and 6. So here, once I do this, is 6. Does it satisfy this? No, it does not. This is false. It cannot equal a sum or difference. So this one is no. And then the last one, I've got a 5 and a 6 here. And again, notice the 6 repeats. So I'm just going to pick the two smallest ones, even though the 6 repeats. So I subtract and add 1 and 11. And because 6 is greater than the difference, but less than the sum, this answer is yes. You're always using the two smaller numbers, and then you will add them and subtract them. Then you don't have to do all three inequalities by adding them and seeing if they're greater than the third side. This simplifies it by just adding and subtracting the two smaller sides And if that third number, that third side, the biggest side, falls in that inequality range, then the answer is yes, they can form a triangle.